If you're a developer, you probably have heard about solid principles. You might have gotten this as an interview question, and it's a very common one. So the problem is there is not so many resources on how to do solid principle actually apply to a React code base. So in this video, I will go through the 5 solid principles, and we will see how we can actually apply them to a ReactJS code base. You can use those examples either to refactor the code you are working on or as an answer to interview questions if you get one. So as we apply those principles to a React code base, what we'll actually see is that we also come up with different React.js patterns like presenter container, custom hooks, render props, and app state architecture. So this is a good sign because it means that applying these timeless principles, you can actually come up with patterns. And so we kind of kill two birds in one stone. So you get to learn both the solid principles and common pattern to apply to React.js code base. Let's start with number 1, the single responsibility principle. And this is one of the easiest to apply, and it basically states that a piece of code or a class should change because of only one reason. But how can we apply that to a React component? Well, let's take this simple example. We have this user profile component, and it's basically fetching some user data from an API, handling the error in loading state, and then finally rendering that. So if we see the component, it kind of looks like it's really oriented around doing one thing. But if we take a closer look, we can see that there is this whole data fetching logic in state management of the data phase that is completely separated from what painting and showing this to the user is. And so if we were to apply the single responsibility principle here, we can divide this into components and have only one of them fetching the data and the other one painting. And this is what we call also the presenter container pattern, where this component will be the container and we have child component responsible for painting the data. If we were to apply this, this is how it looks like. We have the container, it fetches the data, it hands all the state, and then delegates the rendering to the presentation component, which is a stateless component that just does the presentation. If the product manager comes up with a new requirement for how this should be displayed, we only change this part of the code. If the API changes, we only change this part of the code. So all of the sudden, changes coming from different direction would only affect the piece of code, the component relevant to the change. And another example would be to wrap this in a custom hook. So rather than having a container on the container presenter pattern, you could wrap the fetching in a custom hook, and this is how a component will look like. Again, we are using a single component to do everything, but most of the data fetching logic is contained in this hook. It's kind of abstracted away, so you could also apply the single responsibility principle like this. Let's go on with number 2, the open-close principle. What the open-close principle states is that we should be able to alter behavior without necessarily changing code. How does that look like in React? Well, imagine we have a button component that has a handle click function. In this case, the handle click function is hard coded. So whenever I need to change the handle click behavior, imagine I need to send something new to this analytics method. I want to send like some data. I would have to change the component itself. I would have to change the code of the component, and this is what violates the open close principle. If we were to implement this in React and make this open closed, we could actually provide uh, the on click as a prop, and this would allow us to have different functions. So we could change the behavior of the button by changing the on click function without altering the code inside the button component. So on click we could pass this function which was on before, or we could have a different one that also sends maybe the timestamp, or we could add a purchase activity. So we could basically change this on click function to alter this behavior without changing the button. So that's the open close principles. So the next one would be the Liskov substitution. And basically, what Liskov substitution mentions is that any child of a parent class should be able to have all the functionality of the parent. This one is a bit complex, and it's really very relevant if you were working with Java. And in React, it doesn't make any lot of sense because React already solved these problems. One of the main principles behind React philosophy is composition over inheritance, which means rather than inheriting from a component, we build components by putting them together. Pretty much like you would be assembling a car. You take different parts and you put them together in higher order part, and this is what already prevents a lot of the problems. So the Liskov substitution principle is already satisfied in components framework like React. So instead of having like inheritance chain, this would be like, let's say, our final component. It should now inherit from thousands of components before, which will result in very tight coupling. We actually composes these components into higher order one, just like you would assemble a car. So if they ask you about the Liskov substitution principle, don't worry, React already complies with it because React favors composition over inheritance. Moving on to interface segregation, this is another very simple one. Basically what it states is that if I'm consuming or using a component, I shouldn't be getting more props than I actually need. And a very good example, it could be this product card props, and where we have all these interfaces as props, right? We have different props that I need to display a product, but I also have these two to make actions on the product. I could easily split this interface segregation into a component that will only take, the details to display them, and another component that has actions. This is, as you see, very similar to the single responsibility, but it's very oriented to interfaces we expose. So imagine this would be a reusable component that they give others to use, and they just want to display, for example, the product. It's much easier to split this into two different components, so the clients, whoever is using this, only gets what they need. They do not get a huge component with thousands of props that they do not really use, and that are not relevant to their use case. Last but not least, dependency injection. This one is very implemented by backend frameworks, but we would also apply this into React. This basically states that it's better to pass your dependencies as arguments, in this case as props, than directly importing it. We have here a app component. It's using logger, and we make this import to get that logger, which means this is now tightly coupled. We cannot use app.js without having a logger. We cannot use app.js with a different version of logger. It's always the logger we import. If we were to apply dependency injection and we pass logger as a dependency injected into runtime, so whenever someone using an app, they need to pass a logger. We actually have the same behavior with the flexibility. We can pass different object here. So imagine we are testing the app component who could pass a mocked version of logger and actually be able to write a unit test for this. Whereas here we somehow need to override the import and some very sophisticated logic to provide a different logger implementation. So this example right here, it's a lot easier to test and it's not easier to decouple. And finally, how can we actually use Solid when we architect our app? A very common example, React.context that we use to store global state, and it's kind of consolidated in a single context. Like in this example, I have a app provider that has both user information like login, email, name, and then theme. They all together in a single context. The problem here, all the component will have to subscribe to this regardless if they only need the theme or the user. And so whenever someone changes the theme, also all the components that are also needed the user, maybe they do not need the theme state, will also re-render. This is a huge problem. It can generate a performance bottleneck. Instead of having this, we can apply the single responsibility principle and interface segregation principle at the same time and split it into two different contexts that different component can subscribe. Some components would need both. Some of them might only need the theme context and some of them might only need the user context. So solid principles are nothing abstract. They are things you can apply on everyday code basis. You now have some examples you can use in your next coding interview. I'll see you on the next one.